Today we're going to be learning about percent composition. So in order to go and find percent composition, what you're going to be doing today, it's kind of like, what percent did you get on your test? So you're trying to figure out how many, um, I don't know, questions you got correct out of how many questions there were on the test. So if you're finding the percent composition of a compound, you're going to find you're going to analyze the elements in that compound, and you're going to tell me what percent of the whole compound does that element take up and make, okay? So, and you're going to do this by comparing the mass, so that if you are looking at, for example, sodium chloride, you want to see how much mass does the sodium bring. So if we're looking at sodium chloride here, so NaCl, so how much mass does the sodium bring? How much mass does the chlorine bring? There will be a total mass, and then you're going to look at what percent does the sodium make up? What percent does the chlorine make up? Okay, and then present those. So that's what we're trying to find today, percent composition, okay? And we're going to analyze the percentage by analyzing the mass. All right, so here's the general equation. So the percent that the element brings forth, okay, in the compound. So you would take the mass of the element and divide by the total mass of the compound, and then, times it by 100 to get the percent. And then you don't have to have you don't have to have the mass always in grams. It could be in other units. So the main thing is that they have to be the same. So if you're going to do grams, grams should be at the bottom. If you can do milligrams, milligrams should be at the bottom. Kilograms, kilograms at the bottom. Pounds, pounds, whatever, right? So, and then overall here, there is a general equation. This is the one on the back of your formula sheet. You're just going to have percent x equals mass of x divided by mass of total times 100%. So you're looking at taking the mass of the specific item that you're looking for the percentage of, and then dividing it by the total mass of the substance, and then multiplying by 100, okay? All right, there is a law of definite proportions here to say, hey, what if we have, I don't know, 1 gram of sodium chloride versus 100 grams of sodium chloride? Am I going to get a different percentage of sodium to chlorine? No. You're going to still have that same percentage coming out, even if the compound has a greater mass, okay? So in the end, it's still going to be like, a sodium 1-to-1 ratio, and then sodium's always going to bring 22.99 mass, and then chlorine will bring a 35.45 mass, right? So it's still going to be proportional. So that's why even if you have a much greater sample, you're not going to get different percentages coming out, okay? They'll still be the same. All right, so we'll start with some examples here. We're going to start with somewhere, it's straightforward. I'm just giving you the formula or just giving you the compound, and I want you to go and analyze the different elements that make up that compound and the percent composition of those elements, okay? And then from there, I'm going to give you somewhere, what if we're starting off with the mass of the total compound, and I'm going to tell you the mass of one of the elements. Can you go find the mass of the other ones, okay? All right, so the first one here is calcium hydroxide. So you need to come up with a chemical formula. So again, if you're just a little bit hesitant still, just keep doing this, right? Calcium, here we'll do it up above. Calcium is a 2+ charge metal. Hydroxide's a polyatomic. Okay, write it in this order, OH. Okay, put the formula together, and we will have a 1 calcium to 2 hydroxide ratio when you charge balance or crisscross, whatever method you use, okay? All right, so we need to come up with the total mass of this compound. So we'll find the molar mass, right? So this is a way to find the total mass here, okay? So we have 1 calcium, we have 2 oxygens, 2 hydrogens. Okay, so 1 calcium is 40.08, 2 oxygens 16, 2 hydrogens 1.01. Okay, so if we show the work, don't have to show this much, but just get right to the right total with some work. You end up with a total of 74.10, okay, grams per mole. Okay, so from here, you need to figure out the masses of the individual elements. Okay, so what we'll do here to keep ourselves organized is we'll keep put a table together here, okay? So if we're looking at the mass of what calcium contributes to calcium hydroxide, okay, so you see that there's one calcium, okay, in the formula. So one calcium contributes a mass of 40.08, okay? So we saw that when we're finding the molar mass. The oxygen, though, we have two oxygens that contribute to the overall mass, right? So oxygen brings a 32 grams per mole to the mix. And hydrogen. Hydrogen has two of those as well. It brings a 2.02 mass. Okay, and then so with our one calcium hydroxide compound, okay, that brings forth a 74.10. Okay, so that's our grand total. Our total here. Here are all the different masses of the elements that come with calcium hydroxide. So if I want to go and find the percent composition of the elements, compared to the overall compound, this is what we're going to do. So we're going to look at calcium first. Okay, so calcium, right? So remember the formula is you're going to take the mass of the element and then the mass of the total. Okay, and then you're going to multiply by 100%. Okay, so let's do that here. So the mass of calcium, mass that calcium brings forward, all the calcium here, because it's a 1 to the rest of it ratio, is 40, okay, and 40.08. And then the total mass was 74.01 times 100. Okay, so if we divide these, we will get and then let's go 2 decimal places here. Everything's got 2 decimal places. So 54.09%. Okay, so calcium within the calcium hydroxide compound makes up 54.09% by mass, right? Because some of you might be wondering, well, there's only one calcium and there's more of the oxygen hydrogen. But remember calcium, look at where it is on the periodic table. It's a lot lower, right? It's further to the left, right? So if you remember looking at structurally, it's got more protons, more electrons, it's got more electron shells that it's dealing with. So it is a larger element, right? So it's going to have more weight to it, and it's going to, make up a greater percentage here, okay? All right, and then let's go to finding the percentage of oxygen now, okay? It doesn't matter which order you find them, but I'll just go left to right here. Oxygen. All right, so same thing, the mass of oxygen. Remember, it's 2 of them, though. That's what you got to remember. Not just 1, but 2 of the oxygens brings together 32 grams per mole. Compare it to the total. Don't forget to multiply by 100, and you will get 43.18%. Okay, so that's what the 32 grams is bringing forth. Okay, all right, and the last one, we can do the same thing, but I'm going to see if you could think of another way. Okay, so just see if there's another way maybe that some of you might argue it's faster. Otherwise, if you're like, nope, I kind of like how this is going, just keep doing it the same way, go ahead. Okay, so I'll show you the other method in a sec. So hydrogen, so same thing. Hydrogen brings 2.02 divided by the 74. Okay. Oops, I gotta divide. And that's going to bring forth a much smaller percentage here. Hydrogen doesn't weigh much to begin with. So it will only take up, sorry, round this properly, 3. It will take up 2.73%, okay? So obviously because I am rounding up, I'm probably introducing some error here. So if I were to add all 3 of those percentages up now, do I get 100%? 50.09. Yes, actually I do. So that's awesome. Okay. All right. So sometimes you're going to find that you're adding all the percentages up and it's off a little bit. And again, it's because whenever you round early, kind of chop off the accuracy of the answer. So I think because we kept a couple digits like that, it kind of worked out perfectly. Okay. All right. So yeah, that's how you calculate the percent composition of all the different elements for calcium hydroxide. So if you're trying to figure out their fourth statement, we'll do that next. But just for now, if you're wondering what I was talking about before with like, can you figure out the percentage of hydrogen another way? Okay, so I will squeeze in the other possible way this way. And here, here, we'll try this. Okay, so basically, you would have had so far, like after calcium and oxygen, so you would have had calcium had 54.09, right, percent. You would have had oxygen had 43.18%. Okay, so basically, when you find a percent of something, it's percent, right? The word percent is actually per cent, right? Like in French, so per 100. So, so basically, out of 100, calcium hydroxide, 54.09% of the 100, right, makes up calcium. 43.18 of the calcium hydroxide makes up oxygen. So therefore, these numbers should be adding up to 100. So if you wanted to maybe not show all of this work or calculate it the way we did for hydrogen, this is what you could do for the last one that's remaining, okay? You could just go, well, I know it adds up to 100, right, the total. So if I just subtract the two that I just found, okay, so there's the calcium and there's the oxygen, and if I just subtract those from 100, I will get, oops, is that right? I must have typed it. Oh no, I'm totally writing this wrong. I wrote the oxygen incorrectly, so let me fix that. Okay, so if I do this again, so if I subtract those from 100, I will get 2.73%, and that's what we got down here. So some of you might prefer to calculate the last one this way, okay? Because you're just like, well, I know it adds up to 100. I got the other two, so the remaining out of 100 has to be the third element here, or the fourth element, whatever you guys are looking at, okay? All right, so just an alternate way to calculate that very last element, percent composition, okay? All right, so, and then from there, if you're looking at, because I've been emphasizing, try to, communicate your ideas properly here. What is it that you found? You just found the percent composition of calcium hydroxide, okay, to be this percent calcium, this percent oxygen, and this percent hydrogen. Here's our final statement here. Here's the key words. This is what I keep trying to emphasize. The key word is you should know that you found the percent composition, right, of a substance, okay, and the percent composition of calcium hydroxide is 54.09% is calcium, 43.18% is oxygen, and the 2.73% that's remaining is the hydrogen that makes up the calcium hydroxide. Okay, so that's what you're doing today, just finding the percentage of the mass that these different elements are making of the overall total of the sample. Okay, so again, it all comes down to starting with finding the molar mass of something, and then finding the individual masses. And again, remember, if there's two of them, double it up, triple it up, whatever you need to do. And then that's what you do. It's almost like you're finding the percent of a test, right? Find the percentages of each of those elements, and then make a final statement. So I'll let you stop the video here and then try the next one on your own, and then just check, turn the video on to check your answers. Okay, so the next example here is to find the percent composition of sucrose. All right, so don't worry, you don't need to know that formula this year, so I will provide you formulas for those. So we're finding it's 12 carbons, 22 hydrogens, and 11 oxygens. So we go through, calculate everything correctly, get that total mass. From there, when you go to find the individual masses, make sure, pay attention, there were 12 carbons, there are 22 hydrogens, there are 11 oxygens. So you have to use those numbers in order to compare. And then I kind of continue with the table here. I just kind of went down and went, okay, take that, divide by the total, et cetera, et cetera, et cetera, right? So we're just taking the amount, the mass of the element, dividing by the total mass of the compound, and multiplying by 100 to get these percentages here, and then just making a therefore statement. Okay, so the percent composition of sucrose is 42% of it is a carbon, 6.49% is hydrogen, 51.41% is oxygen. Okay, so you're going to find that these examples are a little bit different. Basically, they're in a way trying to help you by giving you some more information, okay? But when it comes down to it, you can just go about calculating these ones the way you did above, right? So if you still in the end need to find the percent composition of aspirin, you have the formula there, so you can find, how much carbon, how much hydrogen, what percent of these elements are making up the aspirin, okay? But we'll try this from a different way here. So we have a clue that there's 500 milligram total of the aspirin. Okay, we went through and analyzed it and found that there's 300 already of the carbon, 800 or 8.08 milligrams of the hydrogen. So we need to find the remaining oxygen, or it doesn't say remaining, but the remaining is oxygen. So can we find the percent composition? So if we're going to go about doing this, so what we have here is we have our mass, we have our masses here. Okay, so we have zero. We have our carbon, so we do have our 9 carbon, and they're telling us the mass is already 300 milligrams, okay? And then we have our 8 hydrogens, and it's saying, experimentally 8.08 milligrams was found. Okay, and then from there, oxygen we're not sure about. There's 4 of those oxygens, but we know the total aspirin compound is bringing forth a 500 milligram mass. Okay, so from there, if you had to find the percent composition here, so I'll just write percent comp. Okay, so all you're going to do is take your mass of your carbon and divide by your mass of your aspirin. Okay, and then we'll times it by 100. We'll write it down here. Okay, so and we're going to find that that's 60%. Okay, so again, if you did it the way you did it above, where you just go and find the mass of the carbon and so forth, you're going to find it's very similar numbers, okay? All right, so the hydrogen, same thing. We're just going to go 8.08 divided by the 500. I know I didn't put the times 100 up top in the previous example. I just didn't have space, but it was there, okay? Oops, so 8.08 divided by the 500 times 100 will end up being 1.62%, like that, okay? So now to find the oxygen, we're going to do what we did before, where we knew it added up to 100, so we can use that method. So if it adds up to 100%, we take away the carbon percentage, and we take away the hydrogen percentage. We'll end up with whatever is left, which is the oxygen, which will be 38.38%. Okay, and yeah, there's the oxygen now. Okay, there's the carbon, hydrogen, oxygen. So now we have our percent composition of our aspirin. We know it's made up of carbon, 60%, 1.62% hydrogen, and 38.38 oxygen. So, oops, yeah, there's the final statement here. Some of you may have been looking at this and thought, maybe, is there another way we can do this? Right? So if we know the total mass is 500, we have 300 for carbon, 808 for hydrogen. So can we, go 500 minus the 300 minus the 8.08? Yes, you can do it this way as well. So we end up with a number of 192 or 91.92. Okay, so this is milligrams as well. So basically, that's how much the oxygen brings forth. So if we take that number and divide it by 500 and times it by 100, we will get 38.38%. 38% as well. Okay, so it works both ways there. So this is a way that you can do find the percent composition of all of the elements. Okay, so again, if you wanted to actually do it the way we did above, where we found the molar mass and then we found the mass of all the different elements, it would work that way as well. So this way here, I don't know, some people would look at that and go, oh, hey, it's a lot less work. The mass is already given to us. So then we just go through and crush it with the percent composition. Okay, so up to you, whatever, if you kind of prefer to have one way of doing it, yeah, then just roll with what you did up here, okay? Otherwise, if you do see how like this is actually cutting down some steps, try to use the numbers that are given to you. Here's the next example. We're given less information about what kind of sample it is. Like we don't know what the final compound formula is, but we're being told that there's only nitrogen and oxygen that make up this compound. We know the, so use a highlighter here. We know that it has a total of 4.4 grams for the whole sample, okay? And then it does have 1.4 grams of the nitrogen, okay? So from here, we need to find the percent composition of whatever this compound is here. Okay, so we just go through, set everything up here. So we know that there's some sort of oxygen involved. There is a nitrogen involved here, okay? And then we have our total compound here. Okay, so since here it doesn't give you much about how many nitrogens per how many oxygens here, we just have to kind of go with the flow of what we have here and compare the masses that were given. Okay, so here right now we don't know the mass of oxygen, right? That's a question mark, but we do know it's 1.4 grams of nitrogen and 4.6 grams. Okay, so regardless of what the however many nitrogens to oxygens there are, we should be able to come up with a fraction, so therefore a percent, okay? So here we'll do the percent composition in this next step. So if we have 1.4 grams contributed from nitrogen, if we divide it by the 4.6 gram total, okay, and then divide these, you're going to get that the nitrogen makes up 30.43% of the total of this compound, okay? All right, so therefore the rest of it has to be oxygen. So in order to find oxygen here, lots of different ways. Let's do all of them, I guess, here. So we know that the 100% is the total, right? So if we know that 30.43% makes up nitrogen, we are just going to subtract it, and the rest of it will be 69.57% has to be the oxygen, right? Okay, or this is the nitrogen. Okay, so that's one way. Some of you might go, yeah, that's nice and easy, okay? Otherwise, we can think of it as, well, could I just take the masses here, the 4.6, and subtract the 1.4, and get 3.20. Yes, we could do it that way, and then, find the percentage by dividing it by the total mass. This is another way, like it's always good to have a couple different ways to approach something so you can always double check your answers. And yes, I get that same percentage here. Okay, so this is another way that you can approach this question. Sometimes you're not given that much information, so you just do the best with what you have there, okay? So we don't know what the ratio of nitrogen to oxygen in this compound, but we do know that 1.40 is nitrogen, and so of a total of 4.6, the rest of it has to be oxygen. And so we can see here that 70%-ish is oxygen, and the rest, 30%-ish, is the nitrogen. Okay, so we can come up with a percent composition here. Okay, so here's my final statement here. One thing I want to point out is, if you want to write percent composition or say percentage composition, both of those are fine. Okay, and then in this case here, we didn't know what the formula was, so I just called it percent composition of this compound is 34% is nitrogen and 69.57% is oxygen. Okay, so again, work on those keywords. So again, you want both of these percent composition. Okay, to be thorough with your communication mark here, to say, hey, that's what it is that I found. here's the details of it, because in the end it's about, what are these elements doing with respect to the whole compound, right? So yeah, this is 30% is nitrogen, 70% is oxygen, okay? But don't round them up, like carry a couple digits here. All right, yeah, so just be able to go both ways. When I just give you a formula, find the percent composition. If I give you little clues, try to use them to your advantage, cut down the work, okay? Otherwise, like, I guess, like with example 6 here, you wouldn't have been able to find the percent composition using the method from like example 1, 2, and 3, right? Or 1 and 2, because you don't have the actual formula. So you just have to roll with what you have. You know the total, one of the elements, so you should be able to figure out the rest of the stuff here, okay? Um, yeah, so just kind of keep looking at these examples here, and yeah, try the practice, try the checkpoints.